I'm Brooke.
Water pollution in developing countries is one of the main contributors to poor health, poor sanitation, and low standard of living, which negatively affects the economy and many people in the lives of many people around the world. In fact,
772 million people around the world still lack access to a basic human right, clean water. This can lead to diseases such as cholera, which can lead to dehydration or sometimes severe diarrhea. This can also lead to death. According to the United Nations, more than 485,000 people a year die due to unsafe water.
Upon seeing these numbers, we immediately had to do some research to try to solve this problem. When we were researching, we had found upon thousands and thousands of ways to purify water, which we thought was amazing. But which one would be the most beneficial for developing countries to obtain? Which one would be the most affordable, the most durable out of all of them? And most importantly, which one would provide the safest water? We found 4 solutions that at least had one of these characteristics. Upon the 4, 1 had all of them. Chlorination. Chlorination is a water purification process in which you use chlorine to purify the water. This solution was the most effective because not only was it cheap, but it did provide safe drinking water. At least that's what we thought. According to Vox News, a chlorination water process actually slashed child mortality in some Kenyan villages. To us, that was a relief. They finally found a way to provide safe drinking water for these developing countries. When we did more research about it, we found that there was one problem: DVPs. DVPs, or chlorinated disinfection byproducts, are created by adding chlorine that is used to clean the water mixed with organic matter. You might be wondering why this would even cause a problem, but Joseph G. Hadersley in a 2000 article for the Journal of Orthomolecular Medicine stated that long-term risk of consuming chlorinated water that had DVPs on it accelerated aging, increased vulnerability to genetic mutation and cancer development, it hindered cholesterol metabolism, and promoted hardening of the arteries. If that isn't alarming, then I don't know what is.
So we took the task of improving and perfecting this solution by using activated carbon that acts as an absorbent from DVPs, through utilizing a filter that is affordable, durable, and portable. To prove that this filtration process would work, we hypothesized that if we added baking soda, a substitute for sodium, it would form ionic bonds through the DVPs, since generally DVPs consist of alkali metals, which when mixed with the element chlorine make octet bonds. So we'll be adding baking soda in the water and testing conductivity with a conductivity tester to show evidence of DVPs.
Activated carbon will act as Velcro to get rid of the chlorine in the water and therefore purify and get rid of any contaminants in the water.
We're about to start right now. We're ready.
Yes, start over document.
So this is our first material. We have water and dirt. Now, look at that water again. Do you think it looks salty? And then we have Clorox, which is a substitute for chlorine. Then we have our activated carbon, and then we have baking soda, and this is just our dirt right here that we were mixing in the water.
So now let's measure the conductivity. Oh shoot. Let's measure the conductivity. It's on. It's on. Oh, it's on. Wait, we didn't put the chlorine in.
A few moments later.
It's clear. We made it. We made it, guys. In our hypothesis, we said that mixing chlorine with baking soda would and then later on measuring the conductivity would show that there was DVPs in the water. That actually went really well when we did the experiment. As you can see, and then as you can see, you could see the light turning green, which meant there was conductivity in the water, and how the water and the organic matter, when we did activated carbon, it changed colors and had a reaction.
What problems did we experience? The problems that we experienced was our coffee filter wasn't thick enough, and so when we pour the Clorox treated water in, some of the activated carbon leaked through and colored the water, contaminating it with more carbon.
So instead of using the Clorox tablets like we were originally going to, we ended up using bleach, and the bleach wasn't as strong as we wanted it to be, so it didn't clean the water as much as we wanted it to do. So for the next time we experiment, we're going to use Clorox tablets, which should be more concentrated, should be more stronger to clean the water like we want it to. And when we were experimenting, we kind of made a big mess, especially with water. So we decided we're going to get a bigger water bottle, so that way it's less of a mess, and the filter could just be more in use, could just be better.
No, just start.
So experiment 2 was a total disaster because we decided to basically experiment with soil instead of dirt. It didn't turn out as we wanted to because when we filtered the carbon,
We're gonna run this through the filter one more time.
The color was yellow, and we filtered it again.
We used soil instead of dirt because it was all that was available. This revision directly affected the experiment outcome because the soil is already fermented, making DBPs impossible to form.
On a larger scale, we expect this product to impact hundreds, if not thousands, of lives in the long run.
Our purpose is to raise awareness for water pollution to be solved in developing countries through this activated carbon filtration. However, it's not so easy when your filter has limitations.
That's why upgrading the filter with a coffee maker structure will give room for developing countries to experience a clean water every day and enjoy it as much as we do.
What do you mean by a coffee maker structure?
Well, our coffee maker structure like this is not only cheap with a difference of $450 in between other filters, but it is portable, lasting up to 7 years compared to other alternatives that usually last up to 6 to 12 months.
We hope that with this new change,
It'll bring happiness to many homes.